In this video, we're going to look at an application style question of integration. So just to start with, it's talking about a bell-shaped chocolate here. If we imagine what a bell would look like, it would be something like this, right? And so what we get is that the cross-sectional area of the bell would just be a circle. Now the area of a circle, I'm sure you guys are aware, is given by pi r squared. And what it's asking for here is, according to the model, the exact volume of one chocolate piece. Now the volume, how we can get to that from the area is by integrating the area, because we know the integral of the area of any 3D shape will give you the volume of the 3D shape. So let's form that expression here. We're finding the volume, which is the integral of the area of the shape, which is given by this curve here, root of Sinhx, with respect to x. But then what are we integrating in between? Well, we're integrating in between when x is 2 ln 3 and when it's 0. Because that's what will give you. So this here, what that represents, by the way, is this length, which is the radius of the curve. So this isn't actually the full expression for the volume, because if this is what is represented by the radius, then we have to not only square that, so that it now becomes just Sinhx itself, but we also have to multiply by pi. And let's include the multiple of pi outside of the integral, because this is just a constant that we're not going to integrate. We're just going to focus on integrating Sinhx with respect to x between 2 ln 3 and 0, and then we're just going to multiply by pi afterwards. So just to recap, we introduced it as pi r squared. R is equal to the root of Sinhx, but because we're squaring r, it will be just Sinhx. Okay, let's now focus on doing this part of the question. Now the integral of Sinhx is just Coshx. I'm getting mixed up now. Yeah, Coshx. And you're still integrating between when it's 2 ln 3 and 0. Sorry, there was a bit of information that was given in the last part of the question, which I've just cut out, and I'll tell you what that piece of information is when we're doing the question. So what you do now is you put the upper and lower limit into this Coshx. So that's cosh of 2 ln 3, all take away cosh of 0. Now you need to know that the cosh of 0 is equal to 1. The cosh of 2 ln 3, it was actually given in the last part of the question. It was for 41 over 9, but you are also expected to know that the cosh of x, you can find it by inputting it into this expression here, replacing x with 2 ln 3, and you eventually will get that it's 41 over 9. In this case, it's pi multiplied by 41 over 9 minus 1. Now I'll show you a trick to subtracting a fraction from a whole number. If the denominators were the same and they were both fractions, it's easy to subtract. And that's why we're going to make 1 9 out of 9, so that the denominators match. And we also know that 9 out of 9 is 1. 41 take away 9 is 32, so we can write this out as 32 over 9. So we have pi multiplied by 32 over 9, which then multiplies to give 32 pi over 9. And that's the final answer to your question. Now, because we are talking about volume, the answer will be in centimeters cubed. And yeah, that's everything for this question. Be sure to leave a like if the video helped and subscribe. I'd appreciate it a lot. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excellineducation.co.uk.